problem on differential calculus. And in our previous class, we looked at some rules of differentiation. And the last one we looked at was product rule. Then also we looked at the quotient rule, the product rule, the quotient rule. Then from product rule, we have y equals to uv, and u and v here are both functions of x. Then dy dx here, which is a derivative, will then be equals to u dv dx plus v du dx. So here we have the formula for product rule. Then also for the quotient rule, we have the relation here when we have y equals to u over v. Also u and v here are both functions of x. Then here dy dx here will then give us v du dx minus u dv dx then over v squared. So we looked at some examples to demonstrate this in our previous live class. So you can as well check them to see how this is solved. Now, quickly, let's solve one question here to demonstrate product rule one more time before we go. Now, find the derivative. Find the derivative of y equals to x squared sine x using product rule. Using product rule from here. Solution from what is given here, we have y equals to x squared sine x. Now, when we compare this with what we have as y equals to uv, here u will be equals to x squared and v here will be equals to sine x. Then, since this formula is what we need here, then we need to find dv dx and also du dx. So here, du dx, differentiating u with respect to x. So here we give us 2x here. Then here, differentiate v with respect to x. Dv dx here becomes cos x. Derivative of sine x is cos x. That's standard derivative. And here, we can now say dy dx will become u dv dx plus v du dx. That is what we have here, u that's x squared, dv dx that's times cos x, then plus v, which is sine x, then times du dx, which is 2x. Then what we have now give us x squared cos x, then plus 2x sine x. So here we have the derivative of what is given there in this given problem. So now in this class, let's move to the next rule of differentiation, which is chain rule. So we have what is called chain rule, and it's also known as derivative of function of a function. So very quickly, what do they mean by chain rule? So from that number 4 here, which is chain rule, so derivative of function of a function. Then from what we have here, let's say y is a function of u, where u as well is a function of x. where u is a function of x, then here it implies that y is a function of a function x. So this is what we have here. So then the derivative here, which will be dy dx, will then be equals to dy du, that is, we have differentiate y with respect to u, then times du dx, differentiate u with respect to x. So this is the formula we have here. So when we multiply this here, we can see that the u can cancel the u, and what we have on the left will still be equals to the right, which will be left with dy dx. So that's the formula we use for chain rule. So now let's look at one example here. The first one, find the derivative of this function y equals to 3x squared plus 2 all squared. Now from here, this follows the function of a function. That is, here we can say let u be equals to what we have in the bracket here, which is 3x squared plus 2. So we can now write y again in terms of u, and we say from here y is now equals to u squared. Then here we can differentiate u with respect to x. That is, we find du dx here, and du dx here will be 6x. From there, also we find dy du here, differentiate y with respect to u, and this gives us 2u. And what do we have from the formula, which means we have dy dx now equals to dy du multiplied by du dx. Then what we have becomes dy dx equals to dy du here, that's 2u, then times du dx here, that's 6x. That is, here, this gives us 12x u from here. Then we can recall that from here, u is same thing as 3x squared plus 2. So when we substitute back the value of u here, so dy dx here will now become 12x multiplied by 3x squared plus 2. So here we have the solution here, which also we can use 12x to open a bracket, and this gives us 36x cubed plus 24x. So that's the derivative of y with respect to x from what we have here in this given problem. So let's look at another example to demonstrate the derivative of a function using chain rule. Now here also number 2 here, we have y equals to 4 divided by we have 4 over into bracket 6 minus x squared, then all squared. So we have this function here, and we have to differentiate. Find dy dx here. Now, when we look at this function given, it's not in form of a quotient, because if it is form of a quotient, here we should have y equals to u over v, where both u and v are both function of x. But in this particular case here, we only have 4 up here, and 4 is just a constant, so it's not a function of x. So therefore, we cannot say we want to use quotient rule here. So let's write this expression another way. And what we have here, we can write it as y equals to 4 times 1 over 6 minus x squared all squared. So this is same thing with what we have. Then recall that when we have 1 over a raised to power n, this is same thing as a raised to power minus n from here. Then, which implies that we can write this as y equals to 4 times into bracket 6 minus x squared all raised to power minus 2 from here. Then, here now, we have this function which will be in form of a function of a function. Now, let u here represent 6 minus x squared. Then it implies that we cannot say y will now be equals to 4u then raised to power minus 2. Then here, differentiate u with respect to x here. We have du dx here will be equals to minus 2x from here. Then also differentiate y with respect to u. Then we have dy du. Here will give us minus 8 u raised to power minus 3. So the method of differentiation here, we multiply the power and the coefficient. 4 times minus 2 give us minus 8. Then you subtract 1 from the power here, minus 2 minus 1, that's minus 3. Now, from here, we recall that dy dx for chain rule will now be dy du multiplied by du dx, which implies here we have dy du here, that's minus 8 u raised to power minus 3, then times du dx minus 2x from here. That is, when we multiply, minus times minus become plus. Then 8 times 2, that's 16. Then x, 16x times u raised to power minus 3. Then we can now substitute here the value of u from what we have here. So here, u is same thing as 6 minus x squared. Then this gives us 16x times 6 minus x squared as u, then raised to power minus 3. So then we can write the final answer and say dy dx then equals to 16x over this minus here has been used as reciprocal, which is divided by 6 minus x squared, which is now raised to power 3 from here. So here we have the derivative of this function using the chain rule from what we have here. So here we can solve some other problem using the same method of chain rule. So let's look at another question from here, which is number 3 on this particular problem. So this actually easy one. So given that y equals to into bracket 2x squared minus x plus 3 all squared. Here, find dy dx. Now here we can also differentiate this from the chain rule, and then we can replace what we have here with a letter. So let u be equals to 2x squared minus x plus 3, which implies that we can have y will now be u squared. So That means y is a function of a function. Then we can differentiate u with respect to x here. So we have du dx here. Du dx becomes 4x minus 1. So that's 4x minus 1. Then also we differentiate y with respect to u. dy du here give us 2u. Then from the formula, which is dy dx will now be equals to dy du multiplied by du dx. Then what we have becomes dy du, that's 2u, times du dx. Here we have 4x minus 1. Then which implies that here we can substitute the value we have as u here, because here we denoted u as this. So dy dx from here will then be equals to, here we have 2 into bracket 2x squared minus x plus 3, then into bracket 4x minus 1. So if we like, we can expand this bracket. And what we have here, using 2 to multiply, this gives us 4x squared minus 2x plus 6, then into bracket 4x minus 1. Then if you like, we can open this bracket, or we might leave it just like that. So this is the derivative of y with respect to x from what is given here using the chain rule. So we can as well solve more of this particular problem. And in order not to, make it more boring, let's stop here in this class and we'll continue from here tomorrow. You're watching Master T Maths class. Subscribe so not to miss out. And you can also reach me on my line if you need any help in mathematics, you want extra lesson for your child. You can reach me on WhatsApp. That's +234 70 37 79 75 70. Be it WhatsApp or call, you can reach me through that. So I appreciate you for joining one more time. So stay tuned and subscribe for more videos. See you next class, and bye for now.